Get the algebraic expressions in the following cases using variables, constants and arithmetic operations. First bit, subtraction of z from y. We need to subtract z from y. In subtraction, we always write this variable first. So subtraction, put negative symbol, then we should write this. So this is the answer for this one. Clear? In subtraction, this variable first, then minus and finally this. Next, second bit. 1/2. 1/2 means 1 by 2 of the sum. Sum means plus of the numbers x and y. See man, sum of x and y. Sum means x plus y. Now 1/2 means 1 by 2 of this. This can also be written as x plus y by 2. This is for the second bit. Next, the number z multiplied by itself. So z multiplied, so put into, by itself means again z. So z we get z power, add the power since bases are same. So 1 plus 1, 2. So z square is the answer for this one. Next, fourth bit, 1/4. 1/4 is nothing but 1 by 4 of the product of numbers p and q. P and q product means p into q. Of this product 1/4. So here you write 1/4 of this, or else p into q is pq. 1 into anything, so no need to write this 1. Denominator 4 as it is. So this is the answer for the fourth bit. Next, numbers x and y both squared. Numbers x and y both squared and added. Squared means x will become x square, y will become y square. Added means add these two, that is x square plus y square. This is for the fifth bit. Next, number 5 added to 3 times the product of numbers m and n. Product of numbers m and n means m into n. Now 3 times the product. 3 times means here you write 3 into 3, 3 times. Number 5 added. So you add 5 to this. So that is nothing but 3mn plus 5. Okay. Next, product of numbers y and z. Product of these two numbers is nothing but y into z, that is yz, subtracted from 10. So subtraction, first we should write this number 10. Subtraction, so minus, now this product yz. So this is the answer for this one. Next, sum of numbers a and b. Sum of numbers a and b is nothing but a plus b, subtracted from their product. So here we have subtracted, so first we should write this. Their product is nothing but a into b, which is ab. Subtraction, so minus. Then this a plus b. Now here we have more than one variable, so we should put in the brackets. So this is the answer for 8th one. Identify the terms and their factors in the following expressions. Show the terms and factors by tree diagrams. How do we do that? See. First A1. We should show in the tree diagrams. So A1 is x minus 3. Now, in this expression, the terms are x and minus 3. So like this, let us write. X does not have any other factors, so leave it here. Minus 3 also you cannot break it again, so leave it here. So this is the answer for A1. Now B. 1 plus x square. In this expression, the terms are this one. First is 1, next is plus x or just x, and then plus x square or just x, plus just x square. 1 we leave it like that, x also leave it. How do we get x square? We get x square by multiplying x and x. So these two are called its factors. Clear? Here 1 as it is, x as it is, but to get x square we multiply x and x, we get x square. So these two are its factors. Next, C1. Y minus y cube. In this expression, the terms are y and minus y cube. Y we leave it like that. Now by multiplying what all will we get? Minus y cube. To get minus y cube, we should multiply minus 1, y, and again y. Minus 1 into y into y into y, we get minus y cube. So these are all the factors of minus y cube. Next, D1. 5xy square plus 7x square y. In this expression, the terms are this 5xy square and this one 7x square y. Now to get this, what all should we multiply? We should multiply 5x, and to get y square we should multiply y and y. When we multiply all these 4, we get this. So these 4 are the factors of this one. Now here, to get this, what all should we multiply? We should multiply 7. To get x square, we should multiply x. To get y, we should put y. When we multiply all these 4, we get this. So this is the tree diagram for D1. Next, E. Minus AB plus 2b square minus 3a square. In this expression, the terms are this minus AB, next plus 2b square, we don't need to specify plus, but if it is minus, compulsory place negative, and this one minus 3a square. If you have negative, compulsory you should put negative. Positive, even if you don't write, doesn't matter. Now by multiplying what all will we get? Minus AB. We should multiply minus 1, A and B to get this. So these are the factors of this. Now what all should we multiply to get 2b square? We should multiply 2 with b and b. When we multiply these three, we get 2b square. Now here, we should multiply minus 3 with a and a to get this. So this is for E. Identify terms and factors in the expressions given below. We should identify terms and factors in all these given expressions. He did not tell us to show in the tree diagram. So how do we show is in the form of a table. See. So first is for expression. Next is for term, and finally the factors. Now A1. A is minus 4x plus 5. Now, in this expression, the terms are this and this, that is minus 4x and 5. Now, to get the factors, what all should we multiply to get minus 4x? We should multiply minus 4 and x to get minus 4x. So, these are its factors, and 5 as it is. This is for A. Now the B1. B is minus 4x plus 5y. Now in this expression, the terms are this and this, minus 4x and 5y. Here it is plus 5y, whether you write plus or not doesn't make any difference. But if you have negative, compulsory put negative. Now factors of minus 4x are minus 4 and x. If we multiply these two, we get this. Now the factors of 5y is 5 and y. When we multiply these two, we get this. So these are its factors. Next, C. 5y plus 3y square. In this expression, the terms are this and this, 5y and 3y square. Factors of 5y is 5 and y. When we multiply these two, we get 5y. And the factors of 3y square is 3y and y. When we multiply these three, we get 3y square. So these are its factors. Next, D. D is xy plus 2x square y square. In this expression, terms are this and this, xy and 2x square y square. Now by multiplying, what all will we get xy? By multiplying x and y. So these are its factors. Now to get 2x square y square, we should multiply 2x, x, y and y. X into x, x square, y into y, y square. When we multiply all this, we get this. So these are the factors of this one. Next, E. E is PQ plus Q. In this expression, the terms are this and this, that is PQ and Q. By multiplying, what all will we get PQ? By multiplying P and Q. So these are its factors, and Q as it is. Next, F. F is 1.2 AB plus minus 2.4 B plus 3.6 A. In this, the terms are this, this and this. That is 1.2 AB and minus 2.4 B and 3.6 A. Plus, whether you write or not doesn't make any difference, but if it is negative, definitely you should specify. Now the factors of this are 1.2, A and B. By multiplying these three we get this, so these three are its factors. Same way here, by multiplying minus 2.4 and B, we get this, so these are its factors. For 3.6A, we should multiply 3.6 and A to get this. So these are its factors. Next, G. G is 3 by 4x plus 1 by 4. Now, in this expression, the terms are this and this, that is 3 by 4x and plus 1 by 4. Now, how do we get 3/4 of x? By multiplying 3/4 and x. By multiplying these two, we get this. So, these two are its factors. And 1 by 4 alone as it is. Now, h. 0.1 p square plus 0.2 q square. In this, the terms are this and this, that is 0.1 p square and 0.2 q square. And the factors, what all should we multiply to get this? We should multiply 0.1 p and p. By multiplying these three, we get this, so these are its factors. Now here we should multiply 0.2 q and q. When we multiply these three, we get this, so these three are its factors. So question is completed. Identify the numerical coefficients of terms other than constants. He has specified other than constants in the following expressions. We show this in the table form. See, first the given expression, and in the next column what all terms are present, and in the next column their coefficients. Okay, next. Now the first bit, it is 5 minus 3t square. Now, in this expression, this is a constant. He told not to consider the constants. So, other term is minus 3t square. And the coefficient for this term is, before the letter whatever number you have got, that is called coefficient. I repeat, before the letter whatever number is present, that is coefficient. We are done with first bit. Next, second bit. 1 plus t square plus t cube. Now, in this expression 1 is a constant, so leave it. Other terms are t term, and this is called t square term, and this is called t cube term. Now the coefficient for this, number before this is 1, so coefficient is 1. Number before this is 1, so coefficient is 1. Number before this is 1, so coefficient is 1. That's it. Next, third bit, x plus 2xy plus 3y. Now this is the x term, so write x. This is xy term, so 2xy, and this is y term, so 3y. Now here x coefficient is number before x, that is 1, and here xy coefficient is number before that is 2, and here number before y is 3, so 3 is the coefficient. That's it. Next, fourth one, 100m plus 1000n. Here the terms are this and this, that is 100m and 1000n. Now the coefficient is number before the letter, that is 100, and here number before the letter is 1000, so 1000 is the coefficient. Okay, next, minus p square q square plus 7pq. See, in this the terms are this and this, that is minus p square q square and 7pq. Now coefficient is number before the letter, that is minus 1, and here number before the letter 7, so 7. Plus, whether you put or not doesn't make any difference, but if you have negative symbol, so you should not miss negative symbol. Next, 1.2a plus 0.8b. In this, the terms are this and this, that is 1.2a and 0.8b. Here the coefficient is number before the letter, that is 1.2, and here number before the letter 0.8. That's it. Next, next is 3.14 r square. In this we have only one term, so write only that 3.14 r square, and the coefficient is number before the letter, that is 3.14. Next, we have 2 times L plus B. Now first let us expand it, or else open the bracket. We get 2L plus 2B. So the terms here are this and this, that is 2L and 2B. So here the coefficient is number before the letter, that is 2, and here number before the letter 2. Next one, 0.1 y plus 0.01 y square. Now here the terms are this and this, that is 0.1 y and 0.01 y square. So here the coefficient is number before or decimal before the letter 0.1. Here also before letter, that is 0.01. So we have completed this question. Identify terms which contain x and give the coefficient of x. We write in the table form. See, first given expression. Next, we need to find which contains x. That means x term is what we need to pick from the given expression, and here we write the coefficient. Okay. Now, the first bit is y square x plus y. Now, in this expression, wherever you have x, that is the x term. We have x here, so this is the x term, that is y square x. And the coefficient is whatever you have before x. We have y square, so y square is the coefficient. That's it. Next, 13y square minus 8yx. In this term, where do you see x? Here. So this is the x term. Don't neglect this negative symbol. Okay. Had it been positive, even if you don't write, fine, but negative symbol you should write. Now, coefficient means whatever you have before x, that is minus 8y. Okay. Next, x plus y plus 2. In this expression, where do you have x? Here. So this is the x term, and the coefficient is whatever you have before x. Nothing is means 1, so put 1. Next, 5 plus z plus zx. Now in this expression, where do you have x? Here. So take this term zx, and the coefficient is whatever you have before x, that is z. Next, 1 plus x plus xy. Now in this expression, where all do you have x? Here and also here. So write both x plus xy. Since you have in both the places, so you take x common from x common. So here you are left with 1, and here x out you are left with y. So now the coefficient is whatever you have after x. After or before doesn't make any difference. Okay. Next, 12 xy square plus 25. Now in this, where do you have x? We have x here. So this is the x term, so you write that 12xy square. Now the coefficient is, leaving x, you write whatever is present, that is 12y square, whether it is before or after. Leaving x, write all in the coefficients. Next, 7x plus xy square. Now, in this, wherever do you have x? Here and here. So write both 7x plus xy square. Now we should take x common. So from this x out, so you are left with 7, plus here also x out, you are left with y square. So the coefficient is, leaving x, whatever you have, write that. So this is the coefficient for this one. Okay. Next, B1. Identify terms which contain y square and give coefficient of y square. Again, I show in the table form. See. Expression here it is coefficient, and here we should write which contains y square. That means y square term is what we need to write. Okay. Now the first one, 8 minus xy square. Now in this, where do you have y square? Here. So this is y square term. Now the coefficient is, leave y square, write the left out, that is minus x. That's it. Next, second bit, 5y square plus 7x. In this, where do you have y square? This is y square, so this is y square term. Now the coefficient is, leave y square, write the rest, that is 5. Okay, next, 2 x square y minus 15 xy square plus 7y square. Now in this, where do you have y square? We have y square here and also here. So write both. That is minus 15 xy square plus 7y square. Clear? Wherever y square is present, we have written. Next. Now you take out y square common, that is outside. So here you are left with minus 15x plus here you are left with 7. Now to get the coefficient, leave y square and whatever is left you write that. So this is the coefficient of y square in this. So the question is completed. Classify into monomials, binomials and trinomials. We show this in the table form. See. Monomials, binomials and trinomials. Now you understand here, monomial is nothing but 1. Mono means 1. So where all you have only one term, that comes under monomial. So from all this, where all do you see only one term present? That is here and here and here. That's it. So we have got y square, 100 and 7mn. Single term, so they are called monomials. Next, binomial means 2 terms. So now let us find out where all do we have 2 terms. We have, here you see 2 terms, so this 2 terms. Here also we have 2 terms, here and also here. So let us write, that is 4y minus 7z, 5 minus 3t, 4p square q minus 4pq square and a square plus b square, z square plus z. Okay. 2 terms come under binomials. Next, trinomial means 3 terms. Where all do we have 3 terms? Here, here and also here. So let us write them here, x plus y minus xy. Next, ab minus a minus b. Next, z square minus 3z plus 8. Next, 1 plus x square. So these are called trinomials. Hope you understood the difference between the three. Monomial means only one term. Binomial means two terms. Trinomial means three terms. State whether a given pair of terms is of like or unlike terms. We show this in the table form. See. Here I write all like terms and here I write all unlike terms. Okay. Now, let us select all the like terms from this given. Now here 100, both are constants, so they are like terms. Now here you should look at the letter. Here it is x, here also x. So this come under like terms. Next, here we have x and here y. Letters are not same, so they are not like. Now here it is xy and here yx. Xy or yx both are same, so the letters are same, so this come under like terms. Now here m square p and mp square are not same. Here the square is on m and here m power 1. M square, here we don't have m square, so these are not like. Next, here xz and here x square z square. We don't have square here, so they don't come under like. So these are like terms and these are unlike terms. That's it. Question is completed. Identify like terms in the following. How do we find it out? See. First, A1. You take the first one, that is minus xy square. Okay. Now, the terms which are like to this should have xy square in it. So let us start seeing. Do we have xy square here? No. So next, xy square do we have here? No. Here we have xy square. So this is a like term to this. Clear? Like terms means you should have xy square. Same letters with the same powers. Now, do we have xy square here? No. Here no. Here no. Here no. Here also no. See, here we have x, but the power is not same. So no. Now here we have x square y. So no, here also we don't have. Here we have only x square. Y is separate, so no. Here also no. Here also no. That's it. Only these two are like. Now, if we take this one, that is minus 4yx square. Now we should look at yx square term. Do we have here? No. Here no, here no, here no, yeah, here. Yx square or x square y both is the same. So this is the like term you write here. 20x square y. See man, both letters and powers have to be same. Yx square or x square y, they are same. That's why they are called like. Now here no, here no, here no, here no. That's it, done. Next, 8x square. Now we should look for x square term. Do we have x square term here? No. Here we have. So write this. Minus 11x square. Now here no, here no, here no, here no, here no. That's it. Next. This is done. Now this one. 7y. Now this is the y term, so you should look for y terms. Here no, here no, here no, here we have. So that you write here. Here no, that's it. Next, minus 100x. Now you look for x term. Here no, here no, here no, here no, here no, here yes. So 3x. Both are having x in it, so they are like terms. Next, minus 11yx. Now you should look for yx or xy term. Here no, here no, here no, here yes. Yx or xy both are same. So these two are like. Next, that is done. Now this minus 6x square. Here we have x square term, so you look for x square. Here no, here no, here no. So to this, we don't have any like term. So these three are already covered. So we are done with the A bit. Next, B1. Starting with 10pq. This is for the B1. Now here we have PQ. You should look for PQ terms. Do we have PQ here? No. Here no. Here no. PQ are there, but the powers are not same. Here QP, yes. So this and these are like. Whether PQ or QP, both are same. Next this, no, 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 no. Yeah, this, yes. QP or PQ, it is the one and the same. Next, here no, here also no. Next, 7p. Here we have P, so you look for only P. This no, this no, this no, this no, this no, 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 this yes. That is 2405p. That no, 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 no. That's it. Next, 8q. Now you should look for q thing. Here no, only q should be present. Here it is present. So minus 100q. Here no, 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 no. That's it. Next, minus p square q square. Now you should look for p square q square term. So here no, no, yeah, here. P square q square or q square p square, they are the same. So they are like terms. Here no, no. Here also no. Since we don't have square on q, this is not like to this. No, no. That's it. Next. Now the constant minus 23. Where all do we have constants? Here, yes. So write that. Nowhere else, done. Next is minus 5p square. Now you should look for p square term, which is present here. That is 701p square. Okay. Next, all are done. This one, 13p square q. Now you should look for p square q thing. Do we have p square q? Yes, this one. P square q or qp square, they are the same. So write here qp square. That's it. So all are done. Clear? The question is completed.